Cool. 1200. Minimum absolute differences. Give me a way of distinct integers. Uh, Find all pairs of elements with the minimum absolute difference of any elements. Return a list of pairs in ascending order. Each pair A B follows A comma B are from array. A is less than B, and B minus A is equal to the absolute minimum absolute difference of any two elements in R. Okay. Yeah, it sounds straightforward, right? Just do a brute force. I'm using Python. Okay. Yeah, just kind of keep track as you go along the way. I think it's probably the right way to go. I'm going to try to be a little bit better about being Pythonic now, so I could just practice stuff that I would like to use when I'm on a contest or in an interview. Though maybe some of it maybe have to explain more. But there's a thing called in itertools. There's a combination which I don't use enough. So but yeah. Oh, I think I was messing around with my shortcuts. Let's go back to standard. I think. Okay. Okay. Oh, oops. I guess we don't need index too, right? Oh, I guess we do need. Wait, do we need index or no? Just elements. This is right. Is that title this? Also, if you if you haven't seen me try to do the contest, I actually put them on YouTube. But I only bring it up because well, it's amusing. I do a commentary on it. Hopefully, it's amusing anyway. It's amusing to me because I always watch back. But in the last contest, I have a lot of issues with off by one errors under array indexing. I just it's not that it's hard. It's just I always forget sometimes what is inclusive and what's not, and I get off by ones as a result. Coming from different languages, it's hard to kind of just keep everything in my mind correct. But yeah. Also, I should do like negative infinity or not negative, just regular infinity. I feel like I don't know what that is in Python. I would just choose a big number and then call it infinity. But I think in future, at some point I should make that distinct. Oh. Hmm. Yeah, I'm doing a little bit. Oh man, the weight length was 10 to 5th, so I didn't even read the problem this much this time. But that's still not that bad. So, okay. So what now is, just make sure it's sorted. So now you know that the minimal will have to always be the minimal element will always be in two adjacent ones, just because unless they're not unique. Are they always unique or distinct? Okay, so that's fine. Because if it's not unique, then you have to do some counting, but that's fine. Okay, so now you can do the thing where let's go A, B, and in this case, you know that A is always smaller than B. In let's just say SID. I learned this trick from doing code reviews of, or just like reviewing the code of some of the top competitors. So hopefully that works, and also hopefully it makes sense. I think that should be good, assuming that they're distinct. Okay. Oh, they just test. I think this one I'm actually kind of a little arrogant and think I'm confident about, but never know, I suppose. Excuse me. Cool. Yeah. So definitely, I think if I were to kind of, oh man, I didn't send a link. I usually I put a link. Okay. Well, here's a link anyway for you to follow along. But yeah, I think this one I made a silly mistake, a mental mistake. Not didn't really cost me per se, but something that I need to be better about is that. And usually I'm good at looking at the constraints, but I actually just didn't look at the constraints because I think for Yeezy in general, they and this is maybe a little bit of meta, but in Yeezys you could probably just do the first algorithm that comes to your mind generally. But in this case, you can actually do the n square one. So just and it cost me like couple of seconds just retyping it and then by sorting it and then looking at adjacent elements. The other thing that, as I mentioned, is kind of to look for is just that is distinct elements, which I didn't, which would have been the same if you do the n square way, but if you do the sorting, then if they're not distinct, then you might run into an issue where, like the same difference can happen multiple times, and you have to do like some or possible pairing type thing, like and that also degenerates into n squared kind of, in that's your output, possibly. So or n choose 2 if you want to be precise, but yeah. So obviously this is dominated by the sort, so this is just going to be n log n. And you only look at adjacent elements, and all these are O of 1 operations. So yeah, n log, so O of n here, kind of, yeah. So overall, a simple problem. Don't know if I would see this in an interview. It's probably a little bit on the easier side, but definitely something that seems pretty okay to get yourself warmed up. So definitely recommend just taking a look at it. But yeah, and sorting is always a key thing to think about because it gives structure to something that you can maybe take advantage of later.